All right, cool. Thanks for coming along, everybody. Got a small group, but a few folks that I know will be super keen to hear about this. And we'll be recording this and putting it up on YouTube for later. So, welcome to the ESIP and USGS Community for Data Integration, Information Technology, and Interoperability Deep Dives webinar series. My name is Dave Blodgett. I run the committee, and this month we have Sylvain Grellet, who I go back quite a ways with in Open Geospatial Consortium water data standards. Sylvain comes from BRGM in France and has a really deep background in both water resources and informatics and hydroinformatics, data modeling, these sorts of things. So very interested to hear what he has for us today. He's going to be presenting on some ongoing work on standardization of water quality data for the most part. Yeah, I'm really curious to hear where you take us here, Sylvain. Thank you so much for being here, and I'll turn it over to you.
Okay, thanks, Dave. Appreciate it. So yeah, I'm from the French Geological Survey. My background is agronomy, and I moved at some point to water information systems. And then since 2008 or 9 or something like that, I've been involved around the OGC hydrology domain working group and many other initiatives like Inspire and more fair data through OGC, W3C, and Research Data Alliance. So Dave wanted me to just share an update on the topic that is on top of the screen. So I just compiled a bunch of slide decks and also reuse some content from colleagues I'm working a lot with, Ilke van der Schaaf from Fraunhofer in Germany and Katharine Schleit in Austria. So topic of today is how can we achieve a fair, interoperable water quality data exchange using international OGC water standards. So in order to just first set the scene, focusing a bit on what do we mean on the international OGC water standards part of the sentence. So the Open Geospatial Consortium, I don't know all of you guys on the line, so I'm just gonna give a quick update. Slides I've grabbed from OGC slide decks as well. So it's basically the place where all geospatial standards are incubated and produced, and they're not only on machine API web services kind of standards, are also on the content and the semantics, and they also go beyond simple geolocated information, and you'll see that in that presentation. They also go deep down into observations and sensors and stuff like that. The members of OGC are, let's say, roughly 1/3 commercial organization, business, 1/3 governmental organization, and 1/3 research and academia. So the organization I belong to, BRGM, is a mixture of governmental and research and academia organization. As I said, there are many standards in OGC that are also on the semantic side, and there is a lot of momentum driven by domain in OGC, and one of them is hydrology. Some other could be meteorology, like marine, aviation, etc., etc. The hydrology domain working group, I guess it's important to also set the scene on that. It's a joint group between OGC and the World Meteorological Organization that goes way back to 2007, something like that. And the idea is that in that umbrella group, we incubate and work and generate afterwards the standards on water that at the end will end up in the World Meteorological Organization information system, but of course in many other organizations as well. So those standards are under the umbrella WaterML 2.0, and the way we've always been working in that hydrology domain working group is through experimentation, and you'll see one of example today. It's the water quality interoperability experiment. So we always do that. If you see my mouse pointer, work on interoperability experiments. We have some conclusion, we feed back to standard groups, and we produce standards and iterate. There is one important entry point. If you want to go to all what's going on in the hydrology domain working group, is that link here. There is a Twiki. This group has a sister group and the Research Data Alliance side that is called Global Water Information Interest Group. And the hydrology domain working group is chaired by Tony Boston in Australia, Sylvain Pecora just to do the liaison with WMO, and Dave, which is on the line today. I'd say group dynamics. I won't go through all of this, but that's just to exemplify how the group works. The group was started 2009 actually, and we had all those interoperability experiments on groundwater, surface water forecasting that generated standards at surface, like WaterML 2.0 time series standards, and the other rating engaging. Then we moved with some work with Dev as well on hydro features, then groundwater ML2. We had a bunch of interoperability experiments on how we could link environmental features. I mentioned the borehole interoperability experiment at the end because borehole/wells groundwater, there is an important overlap. And now we are working on that water quality data exchange exercise. So as you can see on the Twiki, you're able even to go down 2 minutes from the meeting 208. There is quite an important and interesting community there. We have members around the world from different organization type, kind of mimicking what we have in the OGC slide at the beginning, when you have a mixture of private company, research organization, and even international organizations. So we have some example. I mean, the list could be really long, so I just did that in a couple of minutes. And yeah, the suite of standards I mentioned a bit. All those standards are open and documented. They are implemented, as I said, in the WMO information system, but in many organizations, some international, some are more like regional or country-based, in some open source tools as well. And as I presented in some previous slides, are updated with regular contribution from project involving the hydrology domain working group partner. You should consider those domain working group as umbrella discussion group, where at some point, so many organizations raise hand on one topic, and the topic here is this one. Then we trigger a joint activity to find how we can best work together to define a shared way of working. So there are at least 5 parts in the WaterML suite of standards, one on time series, one on rating engaging. This one, surface water feature, is for like blue line networks and lakes and channels, surface water, groundwater, and self-standing, and also description of wells and all the construction around them. And this one is the best practice. So second part of now that we know a bit what we mean by international OGC water standards, what do we mean by achieving fair water quality data exchange? So what the mechanics we've just triggered a couple of years ago is that water quality interoperability experiment. So let's take a couple of minutes to also just get you to know what an interoperability experiment is, because I presume not all of you are familiar with that. So the OGC works like that. You have standards. Most of the time people know about that, but they don't know how to start. So there is that innovation part of the activity where there are different innovation mechanisms. One is being the interoperability experiment, where you just find a topic, organize a group, do the work, and when you're done with the result, then you pass that to the domain working group, like here in our case, hydro domain working group, to conclude whether there is an interest in setting up a new standards or updating a previous one. And then you go to the standard development part. So what I'm talking about today is on the innovation side, left side of the screen. It's an interoperability experiment. So I also say that there are various kind of innovation activities in OGC. Interoperability experiment to stand here. So you can see that kind of covering a very vast spectrum, potential spectrum with regard to technology readiness level. But yeah, it's really flexible, a flexible mechanism. So this is also a bit of text presented by OGC. I just grabbed that for the sake of introducing that to you. what we do in interoperability experiment is that we start with a domain question. Here it's how can we exchange water quality data, and with the current OGC standards, what we call the OGC baseline. And we just try and do what we can with the current standards. We push them to their limits and extend them if need be, or just fill in the gaps if we feel there is a need for new standards. With regard participation, non-OGC member are allowed, usually as observer, but most of the IEs, I would say IE for now, just to say interoperability experiments, it's more compact. Most of the IEs I've been involved in are using an open GitHub, mailing list, open meetings, open Google Docs for minutes. So yeah, you are observer, but in a way you can be really proactive if you want to get involved. The output of an engineering interoperability experiment, an IE, is to be an engineering report, but the content of it is up to the group that does the work. So I've seen projects where we are kind of more exploring and we just give conclusions, and some of them are even 95% close to actually to an actual standard. Like when we were working on the groundwater IE number 2, it was exactly like that. So the content, the output of an IE is really flexible. And that's what I wrote at the bottom of the slide. It's really during that exercise that the group decides what the output will be through experimentation. So scoping down a bit, the water quality IE itself, that's the third time the topic was proposed in the hydrology domain working group. And now we had enough momentum, enough interested parties to just say, okay, I want to involve staff for quite a long time period to work on the topic. So we had a workshop in March 2022. You have the link on the wiki, and like 3 days workshop with several international organizations that confirmed the necessity of working together on that, identify interested organizations. And we concluded that the best approach to come up with something would be setting up an interoperability experiment. So apart from the OGC process, we kicked that off in September 2022. I'm co-chairing it with Skylanda from the Lincoln Institute. And since then, we've had weekly meetings. The starting point, if you want to get to know what we do in more details, there is just that GitHub link to remember. And from that, you have the dispatch with all the content. Some of it I will present today. And we have shared material rolling Google Docs. We have one focal point for UML models. We have a shared deployment documentation. By the way, all the images on the screens are work in progress. So that is being currently testing, and we will summarize our conclusion in the engineering report. So how did we scope our work? The first exercise was obviously to start with the use cases, of a classical way of working. And we summarize all the proposed use cases in that table. So we mixed both surface and groundwater together in that table. So yeah, that water quality interoperability experiment is both for surface and groundwater data. So feature of interest here means the feature on about which we're interested. And we had obviously the need for data acquired by sample and sensors in situ and ex situ. You will hear that a lot in my presentation. So yeah, the topic is water quality, but quantity, when you do water quality, you need quantity data. So we also had a need for retrieving some quantity data. So that's more, it's not the scope of the exercise per se, but that is support for water quality. So we identify physical properties like temperature, conductivity, chemistry, could be on-site or ex situ, like nitrates or arsenic concentration, just for sake of the example. Biology, especially in surface water, is a compartment of water quality as well. And we had whole discussion on hydro models, remote sensing. So we focused on those first in physical properties and chemistry. And out of scope of the IE, we concluded that we won't have enough time, at least for first iteration of an IE, to decently work on biology, because that's important topic, big topic. And we also excluded for the scope of this first, i.e. Hydro models and remote sensing. So progressively reducing what we do. Then the work methodology, and you'll see that diagram a lot in, in some core places of the presentation. That's the cascade we followed. So from the per use case, kind of doodling, drawing the domain needs, just to also reduce the entry ticket for the participant. Then we went through porting those drawings, doodling to semantics, conceptual modeling stuff. Then when we were clean on what we wanted to actually exchange together, which API, which web service we wanna use, and then when we're clear on how to deploy it, which API we want to use, configure and use it, then implement it on the various information systems of the participants to proof of concept that on the server and client side and iterate. That's exactly the cascade we applied. So first, I will try to give focus on A/B, then C, then D, and some conclusion. That's the thread I want to follow today. So the first focus is on the domain needs and the semantic modeling exercise we went through. So conceptual modeling, we could discuss if you want conceptual/logical modeling, but let's call that conceptual for today. So the first step was indeed expressing the domain need from the use cases, because we also need to take into account the fact that the partners of the IEs are not all of them are expert in OGC semantic standards. Some of them are pure domain standards or more accustomed to their national or organization model. So you don't, and that's important to also have those profiles on board, and it takes time to get the group to have a common understanding of what they actually want to exchange on the domain side, but on how can we formalize their needs in a common, let's say, notation. So we started with this kind of boxes and arrows kind of drawings, a discussion like that, and all those are online. I just had to date them because we went back and forth, iterate on that. Then the second step, once the group started to add some consensus on where and finding similarities across, I don't know, like USGS, WQX, what we've got in France and another organization, we said, okay, we have identified similarities in the needs. So how can we fulfill those needs through the current standards? Okay, what are the current standards we could use? So there is an important need around exchanging observation, measurement, and samples. There is a standards for that. Observation, measurement, and sample that actually was revised, finalized in 2023 after 3 or 4 years of work on that. So it's OMS, observation, measurement, and sample, used in many domains, and I have 1 or 2 slides on that. And when it went down to the domain, more water domain, so you could leverage on groundwater ML for the groundwater features and hydro feature for the surface features. Then the third step is obviously to reconcile the two first steps, and we had to port in a way all those doodling schema boxes and arrows into UML notation. And first good news of that presentation is, I don't know, I didn't do the math, but it's like, I'd say a rule of thumb, 90% of what was needed was actually modeled in the standard that just presented in the previous slide. So no need to specify new classes, new concepts, just use and apply what's in the standards. And UML has a good type of diagram for that. It's called object diagrams. So it's explaining people how you feed, and you will have better example afterwards. One class called, I don't know, type observation or hydro unit from the standards themselves with real data. It's more accompanying people into using standards at some point here. So the backbone, as I said, most of the need was around exchanging observation and measurement taken in situ or ex situ and on samples. The core of the exercise was around observation, measurement, and sample, recently revised. We had the luck to have in the water quality IE members 3 out of the 4 chairs, co-chairs, and last editors of the OMS, so including myself, Catherine Schleid, Ilke van der Schaaf, which are actually mentioned in my first slide. So it was a good way also, we had a good knowledge of OMS. It was a nice way to transfer that to new people and also apply the OMS to water quality domain. So for those who don't know observation, measurement, and sample, I gave you a link to one presentation Katy did, but the long story short could be summarized, at least on the observation side, like that. The basic approach would be that to say that the color of that face is yellow, end of story. But if I just tell that to you, you don't know how I identify the fact that the face is yellow and which method, who observed that, how, and stuff like that. So the OMS approach, at least on the observation side, would be to say that those words are actually words from the standards. My feature of interest is the face. I observed what? The color of that face using that procedure by that observer was still there, and the result is yellow. And you have also obviously other attributes to say, like, when did you do that? You could actually also have validity, quality information, but that's the long story short. The actual conceptual model for OMS look like that. That's a conceptual schema where you do actually have the same thing as I presented. You observe a feature of interest. Actually, you observe a property of a feature of interest using a procedure. What is observing? It could be just an observer or more complex deployment of an observer on a host. That's for the observation part. And that's not a new standard. OMS is the revision of what was called observation and measurement, who went back to 2011. And when revising it, we emphasize on the sample part because many people overlook that there was already a part dedicated in the previous version of the standard around the act of sampling, of taking physical artifact of the real world. Like, could be water, it could be a piece of rock, it could be a cell to analyze and stuff like that. So there is a big part around that, the fact that a sampler realizes an act of sampling that generates a sample from something, etc., and you can link it back to the observation. And obviously, for those of you here that know water quality, you already anticipate the fact that we'll reuse that or part a lot as well. And let me just go back. You'll notice that I'm just changing that picture on the left side. Where I'm trying to give you some context on the standard, I will just go back to that kind of image. And when we go back to water quality, I'm just using a water-related image. Okay, so to give you a bit more concrete content, let's look at some quick image of the models we've generated. So conceptual modeling, the work was organized around the identified use cases. Everything is available on the OGC Sparks Cloud interface tool, so you can log there, even read-only stuff. You can have access to everything we did. We have the naming convention. For groundwater will be GW, surface water will be SW. We have the exact same pattern between in situ quantity, in situ quality, ex situ quality, like exactly here. Same pattern as well. We've worked on them separately, and at some point, we concluded that we followed two main modeling patterns. There is a grouping of what we would call in situ sensor observation, and obviously, groundwater in situ quantity and quality do follow the same pattern, as well as in surface water in situ and quality and quantity. And the ex situ one, meaning that when you take a water sample and you go to the lab, that's an augmented, in a way, not completely different, but a bit augmented pattern. So let's start with the groundwater in situ quantity observation. So there's groundwater level. The pattern is more or less the following. You deploy on a well a sensor. that sensor has what we call observing capability. And what in a, let's say, a layman term, the observing capability is basically saying that that sensor is observing that hydrogeo unit. And actually, what is it observing? A bunch of observed properties, each of them with the accompanying procedure. You could, that's a description of what you deploy in the field. And then your device on the field obviously acquires observation. So this is how you would model that from one observation. Then you will also link that sensor that generate that observation and result, and the observation. If you remember a bit what I said about international observation and measurement and sample standard, the observation will claim back that it is about that same hydrogeo unit and that same property and procedure. So you kind of consistency on right and left side of the screen, and you have that additional spatial sample information that come with OMS. And if you remove those simplification boxes, these are actually, I know it's hard to read, but you can read in a downloaded presentation. This, I just filled that out from an actual hydrogeo unit in France. This one is somewhere in France, and the observed properties, I never remember that was a groundwater level depth. The well is actually one from our information system, etc. So this is exactly what we use a lot, that type of UML object diagram. That is very convenient to explain people how there is no need to take a white sheet of paper and invent concepts where everything is already in the standards. We kind of documenting how to use that. We had to extend in some parts really slightly some elements, but the core is covered. That's important. And okay, I presented how you have that for one observation, and obviously you have the same well that has the same sensor that acquires the same that monitors the same properties to still the same feature, but you have another observation. And when you group two observation in what is called in OMS an observation collection, you have the good old time series with its characteristics and stuff like that. So that's how we would model conceptually the time series notion. Then I will accelerate a bit because I had some of those patterns from an older presentation, and there is no need to detail them in so much emphasis. Groundwater temperature is exactly so into quality. We have sensors on the field that do acquire temperature and conductivity value. We could model that exact same way. There's that we have the same pattern here, and we should just change basically the observed property from groundwater level to temperature, and the procedure changes a bit. But the big picture is exactly the same informatically or data speaking. And you still have the capacity to group in time series and stuff like that. So going back for a sec. This is the one. Which if we move up, I would say first surface water, here back to quantity, river flow can exactly be bundled the same way, just that we don't deploy the sensor anymore on a well, we just deploy that in a water quantity station. We don't monitor an hydrogeo unit anymore, we monitor a water body, which we could describe building or work on the OGC hydro feature standards. I forgot to say that groundwater body before could be described using groundwater now too. So here we're on surface water, and then again, if you get the drill, you just understand that the same pattern, and you will have just to adjust the observed property according to your use case and the procedure as well. In situ quality for surface water goes the same way, like pH, temperature is a good example. And yeah, that's it for the in situ patterns. If we go to ex situ, so again, when you take a sample, water samples to a lab, that's what we call it ex situ. And the example here on screen is on dissolved oxygen and pH. So it's slightly different, but the difference resides more here in introducing sampling and material sample. The material sample in OMS is the field of water you take to the lab. You still have that water quality station. We still have the observing capability I mentioned. We are not detailing the observing procedure on that image because it would be too big. But the long story short is you have on the field, you have one sampling act, but a water body at a given location that generates one or more, in that example, it's one material sample, and that material sample goes to the lab for what? Observation, and then you have the same pattern as before. Observation is about a feature of interest. In other schemas, we have linked here. On property of a feature of interest, using a procedure, you have a result, and the same drill over and over, pH the same way. That's one example I took from one water quality station from French Water Information System next to where I live. There are actual values, so it's not just only theory. Just again, those object diagrams are really interesting and useful. This example on groundwater as ex situ is exactly the same pattern. Just the slight difference is just that I use that one to exemplify the fact that OMS support the fact that you can sub-sample. So you have the same pattern as on the slide before. You have a sampling act. Here we are on groundwater, so it's an hydrogen unit at a given location. We generate a sample. One part of this can directly go to lab for nitrate observation. But if you want to run arsenic concentration analysis, we need to stabilize the physical sample before it reaches the lab. So we obviously, from a first material sample, you subsample it into another one. You can describe the preparation steps, and then you push it to the lab. That's what domain people do, and that's how we would describe that using the standard. And these are actual values as well from information system. So this was a sub-deep dive in those drawing domain needs and how do you do the semantic modeling. Then how can we exchange that now that the group has a common understanding on what we want to achieve? Which interoperable API should we use? So on the table, mainly we had two available options. OGC Web Feature Service or OGC API features for the new API. Yeah, but in a way, in OMS, all the concepts are exchange our features. So conceptually that could work. API feature, even WFS are not tied to a specific semantic model, and the query mechanism is quite limited when you go to observation. I mean, it's kind of generic SQL approach and stuff like that. The other approach we had on the table was OGC SensorThings API, which comes out of the box with semantics that is really close. I did not say tied, but close to observation measurement. This version of the standard, and the query mechanics are really powerful. It's based on OASISO data, and it goes down to filtering, sub-filtering data, and in that case, observation data, because semantic of the API is around OMS 1M. That's, I mean, we will have example afterwards that works super well. So we took the decision to use OGC SensorThings API for observations and sample data, and also to share a bit of geospatial features, river, aquifer, well information. That's core of the work we're doing, and that's mainly what I present here. And to use OGC API features, WFS, just for pure geospatial features description. Let's say that here you would have your river identifier, a name, and here, if you want to know more, and a bit of geometry, if you want to know more about those features, you could also serve them via a WFS API feature, but the core of the observation exchange and sample data comes with SensorThings. Couple set the scene slides on OGC SensorThings API. So it's an OGC standard for exchanging sensor data and metadata, both historic and current. So it's truly RESTful. It could work in read, but also write mode. You have that on the slide afterwards. Building on OASISO data. It supports MQTT, by the way. It provides a payload in JSON out of the box, but we have other serializations. And it's really, yeah, discoverable via the web browser. I should have added on that slide that you can consider it as the natural successor of the old OGC sensor observation service, but way more powerful. SensorThings model, introducing it with that simple example using layman's term, and then the next slide is introducing terms from the standard. Let's say we observe rainfall using that type of sensor on that meteo station around that feature of interest, so the zone around the station that generate observation, and you have a rainfall time series. Just introduce a term from the standard in SensorThings API, you still have observed property, observation, feature of interest. You just have the time series observation collection would be called data stream. Okay. The sensor type in that version is called sensor, and your station observing device would be your thing. And that actually could move, but that's not exactly what we use so much in water quality IE. And that's the real model using the image as the previous slides. So you see a bunch of properties, each property for each class, and then each class can be extended also with, if you want to go beyond the initial model from the spec. So for those who will be interested, there are, I just gave a few links. The top one is very interesting because just look at the amount of observation, and actually that number is way above right today. That's taken from some European air quality reportings that has been, let's say, twisted into SensorThings. It's connected, this one is connected to Windy, and I guess it receives like kind of 4 million queries a day, and just quite performant and stable. Does the SensorThings API can be queried using HTTP and MQTT. You can get a lot of things, but also you can also update and delete stuff. And that's the usual pattern with, like type, and then you can pass the ID and stuff like that. You can go crazy on queries. This one actually provides you everything you need to just generate a map with station. You click on them and you have observation and stuff like that. There is actually a link to that air quality endpoint if you want to look at what comes back with the payload. But you can also have super simple queries. This one is a kind of a really fancy one. What is important here is that the filtering is really powerful. You can select the amount of information you want to retrieve back from a server, and you can also expand. So let me just roll back for a sec to the model. You could start your query here, and you want to know more about data stream, so you will expand to add more data stream time series information. You could also expand in kind of traversing the link. That thing, you can sync graph when you do data, and that's the beauty of SensorThings here. Moving on, I'm just looking at the time as well. I will be quite fast here, but what we did is we started with our conceptual logical model, and we mapped it to SensorThings API standard. So all the terms here on the left side are those from the modeling exercise. On the right side, it's where we mapped that to the model, and we had some missing classes, so we had to deal with that. But first was, thing that's your host in a model. The data stream is time series, I say that already. And the observation can be on in situ stuff, but could be also on samples. So we have to deal with samples. So what you'll see in the next slides is how we extended SensorThings 1.1 standard. WQIE means water quality IE. So in green are the additions, and what we did when added, most of the things we added were additions with the current terminology from the observation, measurement, and sample standard. So conceptually, we're not creating new notions. We're just making SensorThings capable of exchanging semantics that are fully described in OMS. So in between the pre-existing classes, we added the notion of deployment. So in OMS, we have host, deployment, observer. So we added that deployment. After a couple of years of use in the SensorThings 1.0 and 1.1 in the SensorThings community, there were a lot of debate between some people using sensor for sensor type or sensor instance. It's crystal clear in OMS. We introduced back the observing procedure. So we have a clear divide of the procedure is what you do, and the sensor is your actual device that measures. we introduced all that is around sampling and the sampler and procedures and stuff like that. And we also enriched the feature of interest from SensorThings to enable it describe our rivers or aquifer or ultimate feature of interest, but also the samples. And we'll kind of soft typing for feature type. Given that there, after also a couple of years of using SensorThings, also in OMS, a lot of features can be related to another. Like you can relate an observation to another. You can relate a collection to another, etc., etc. So we introduce as well a relation extension, so that comes with Pink in the schema, and that's the output of our work. So we have the initial SensorThings 1.1 classes in let's say blue stuff. In green, it's the OMS addition, so that SensorThings on screen is compliant to the recent revision of observation, measurement, and sample. And in pink is a way to relate many things together. There is a good point around that, is even without the water quality IE, we had to do that because SensorThings 1.1 was based on the first version of the previous version of observation and measurement. Even that the semantic baseline move was revised, OMS was revised in 2023. So we had any way to revise SensorThings 2.0. So that water quality IE, along with another IE on geotechnics, paved the way to the new SensorThings 2.0 that is incubating. So we decided to build on an enriched SensorThings for water quality that is more or less paving the way to SensorThings 2.0. Now down to the proof of concept. Sorry. So implementation. There are a lot of implementation exercise going on right now. In the US, there is, let's say, a US node with USGS EPA and data stream data. We're working in France on the French Water Information System data. Fraunhofer is doing this work on German data, and BAFG, German organization, on the UNESCO GEMS water quality database, or international water quality database. We have 2 other EU projects, at least, that are also reusing that same OGC activity. Also, not to reinvent the wheel in too many places, just use one spec and contribute back to that. It's more comprehensive. So we have other implementation nodes going there and there. And what people are deploying is that we also have Fraunhofer in the IE. So we have already not. I presented a SensorThings API model extension, but it's not just theory. It's applied in Frost. That is one of the most used SensorThings implementation. So we have a tool to deploy and with a Docker image, and I will take a second to drink some water. Implementation. Who, what, how? So we also worked on writing a documentation to help the informatics and domain teams in the various implementation nodes to do the work. So Hilke from Fraunhofer had a up and running free service where we could just push data and all. I gave you the link. I will have to check with Kyle at some point, but that's the link we have for now. And some maps that are running on them, US map, done by the Internet of Water team, and also we could also reuse the generic SensorThings viewer from Fraunhofer as well. It's a standard, so you can use many viewers actually. It thinks what you can do with the WMS, for example. You can do that with SensorThings and share observation data. And we even tested consuming that endpoint and some others with a recent and currently being updated USGS SensorThings API plugin. That's the beauty of standards. Conclusion, after so much theory, it works. I just grabbed a couple screenshots. This is an example of the test area chosen by Kyle and his team. Close to Detroit, and this is dissolved nitrate at River Rouge here. That's Internet of USGS Internet of Water data. I hope I'm okay. Maybe I forgot to write EPA. Yeah, I'm not a US specialist. This is an example cross-border between a station on the Rhine River from the French system, French Office of Biodiversity, OFB, and here that's the station, same river, but from the German land that is just on the other side of the border. That example was on calcium data. And if we generalize a bit what we get and that cross-border French-German example, if you, I guess, yeah, it's another station close to Karlsruhe. And you can see that you can really put next to the other blue and orange data from French system, and this one from the German system. So we can discuss a lot of the value, but the shape would look more or less the same. So that's a nice example of interoperable data. Quick teaser, the next step is obviously to align the vocabs here, because machinely speaking, yeah, you cannot really so obviously deduct that it's the same observed property. Quick conclusion on that. So what's planned? We plan to land the IE normally at the June session of the hydrology domain working group with a demo of all this. And then we'll have to work on the engineering report I mentioned many times in introduction, summarizing the findings, and the engineering report. I'm pretty sure I will propose to finalize best practice for water quality data exchange. So review the water ML 2.0 part 5, and potentially a revision of part 1 time series, because that one was specified in 2009, with 15 years ago. The previous version of ONM when we were using sensor observation service. And this one was, yeah, we have many proof and elements to help craft a revision of this one, building on a new version of the standards and using SensorThings. Steps after the IE. So after, we will have to do what's in the engineering report conclusion, finalize that best practice. And this is exactly what I said before. Potentially, then we could work on shared control vocab. Remember when I just gave the French-German example, we need to work together on how collectively in the water topic we can describe our observed properties and observing procedure and other catalysts. On the current use case, we have more implementation coming. La Plata basin countries through WMO are jumping in progressively. We will have more waterfall and geological survey for Europe partners in those project jump in. And we also may want to address, I hope we will address the other use cases, like starting from the biology and the others. So yeah, we have enough material for a second iteration if everyone has the energy for that. Hindsight on all this, and Dave just wrote that in an email. The question: how is the new OMS meaningful to the IE? I hope I was clear when presenting. We have two good news here. Most of what needed, at least for that first level of expression of needs from domain people, is already in the semantic baseline. So it's great news. We just need to document how and provide a best practice to the community for maximum reuse. And the second good news is we build it on an API that is very powerful, comes with good performances, at least on the implementation I know, and that was already compliant to ONM. So we just had to enrich it so that like all the sampling part are on board, and this will stay because this is now embedded in SensorThings 2.0 working draft. So it's not like we've been crafting a water quality specific extension of SensorThings. No, those extension can also be reused for, I don't know, like rock samples, like geotechnics. People could use the same classes, and so it's nice as well. So yeah, long story short, there was no need to reinvent the wheel. Just use the available standards, document, and enrich them a bit, contribute back to the standardization loop. Well, I guess it's my last slide. on our side, two of the projects that just help support that work in France, there is a One Water project that targets setting up fair water data exchange in France, both on a public organization and research organization, with a decent duration of project. And there is that big EU joint research partnership called Water for All that targets the same things, and also huge amount of organizations. I guess we're close to 90 something. So we have nice momentum in Europe. And yeah, nice word. Your projects also, if you run water project on your side, on your organization, you could join the effort. And I guess also one of the last take-home message would be the Hydro Domain Working Group is a nice place to have such discussion. Oh, you're doing the same project, the same topic, let's just team up together to join the OGC Hydro Way. And thank you, and also keep the opportunity to also thank Katie and Ilke on the material and support on the exercise. So I'm done, and I'm passing the mic back to Dave and his colleagues. And if you guys have questions, feel free to just shoot them. I'll do my best to answer.
Cool. Yeah, no, thank you so much. Really good to get a catch up. I'm guilty of not keeping up with what you guys have been doing. And it's good to see. But I will open the floor to anybody on the line who has questions. I certainly could seed, but see if anybody wants to jump in. Well, so I guess the one thing that caught my eye that I'm curious if you could talk a little bit more about is you made the point of saying that you kind of separated procedure into the sensor and the procedure separately.
In SensorThings, yes. Mm-hmm.
Yeah. So is that something that was introduced conceptually in observations and measurements and samples, or is that was a SensorThings?
No.
Change?
It was yeah, indeed. It was from day one in OMS. I should have enrolled back to the sample. Okay, here. That's OMS, so that's the semantics backbone, and you already have I'm observing a property of a feature of interest using a procedure, and that's the how you tie a property and procedure stuff. And the other side is more, the right side is more the actual deployment of the system you deployed. So you are the host on which you deployed a sensor, for example. We named observer on purpose in OMS because sensor was too semantically focused on IT devices, while we know that like biodiversity organization, for example, do also use OMS. So observer could be a human. So we already had that divide. It's not new, actually. It's more that SensorThings initially just had one class, and we saw that the community had long discussion around that.
Yeah, I've always felt like that was a kind of a problematic point in the idea of a procedure, and it's good to see that separation kind of be taken practically like that.
And to be a bit more comprehensive in my answer, if you open O&M, so previous version of the same ISO standard that is on screen, you did not, those also deployment observer, they were not in O&M. So in O&M, you had that OM process that has exactly the same discussion issues that we had in SensorThings 1.1. And we added from the W3C SOSA experience, those three guys. So they are not called the same way in SOSA, but it's the same trinity, I would say. So now it's clear we can do clean dispatch from machine-to-machine point of view.
Yeah, that's good. That's great.
I had kind of a similar question. I think it's similar about, one of the things we're trying to do is put like the solar charging system data, like the amps drawn and voltage. And well, the like industrial IoT protocols are more standardized. The idea of having it in sensor things is good because you can have it with the environmental data as well, you know. And another thing of that is we're trying to put like the sensor serial numbers and the calibration data of the sensors.
Sure.
So it sounds like that's what you and David were just talking about, right? You can do that.
Yeah, indeed. And it's interesting because my colleagues are working on those servers, so I cannot access them. I wish I could have displayed that, but our actual groundwater sensor on the field, we have probes and they measure like groundwater level, conductivity, temperature, and they push through GPRS their observation. But our sensor, our piezometers, they actually also serve back the battery voltage status. So that in a way, it's useful to plan when you need to revisit and go back on the field to check that the battery is okay and stuff like that. So
Yeah.
it's really mixing both use cases.
So is there a forum to discuss these questions?
So there are two forums in a way in OGC. If you are more on the water, but there are two forums, but there are overlaps in people. For example, myself, but some others are involved with several ads. So you could meet the same crowd partially. So there is the hydrology domain working group. It's really a really nice umbrella to discuss water topics and also to share together that each organization, what project do we have running in our various countries / continent, then we can team up. That's a nice way to align planet and trigger activities. And there is another group that is worth mentioning. It's the observation domain working group and the standard working group for OMS. Here it's more observation centric, centric. And this one is more meta. As you can see, there is no water in that screen. And I'm a co-chair of the other, or OMS, and we have nice discussion with people coming from like the marine environment, satellite as well, and I mean many communities, aviation and stuff like that. So it depends whether you're more observation sensor or more water, but anyways, there is an overlap.
Here, thanks. I'll check with Dave Blodgett and see if he can point me in the right direction.
Yeah,
Thanks.
and from our organization, Candace Hopkins
Yes.
is also taking part and Lee Stanish, I believe, is also kind of in the mix. But
indeed,
yeah,
Lee and
so-
Candice are in every water quality IE webcoms.
Yeah.
And big thumb up to all people in the US and in Canada side because they are early breakfast webcam for them.
Well,
For once, I'm not staying up too late.
And thank you for staying up late for this one.
No, this one, no worries. This one is okay.
Yeah. So we're out of time. Thank you so much for the overview, Sylvain. It's really good to see you and hear the update. And if folks have questions, feel free to get in touch with me directly or Sylvain.
Yeah.
And we're happy to follow up. So have a good afternoon, everybody, and good night, Sylvain.
Bye, everyone. Well, nice to talk with you. Bye.
See ya.